Okay, so we're going to actually do something kind of fun over the next several classes. No, something even cooler. We're going to solve a real-world problem. Well, before we've done kind of drills, messing around with things. Well, I met with a potential client this morning, and he gave me some stuff that we're going to be quoting out for a project.
Are we getting paid for this?
No, we're not writing a graphical application or anything. So, but there's aspects of this that would be very, very cool. So I figured, why don't we take a real-world problem and solve it? This is something you might do algorithmically in the workplace. So the idea would be this. So who's the client? The client is a golf company called Seymour Putters. Okay, kind of a famous small golf putter company. They make these custom putters for people, and they think their putters are better than other people's putters, blah, blah, blah. But anyways, what they're looking to do is create a custom fitting type of application for allowing people to see how their putting is improving in golf. And they've broken it down into 4 pieces. So they say that it's aiming, start line, short putting, and lag putting. All right, so 4 different things that they want to capture. And for each of these, they're going to be taking in 10 putts. So when they're doing aiming, they're going to have you step up, take 10 putts, and then do some measurements on those putts. Well, we're going to write a program that we'll write a data structure that reads in those 10 pieces of information. We'll manually enter them in and gives you an output. So the output that they have on a per category basis, so per category, is they have 4 is a Tour Pro, 3 is a Tour Pro, 2 is Top College, 1 is Top College, 0 is college. Oh, sorry. Did I spell it right?
Mm-hmm. Yeah.
That looks really funny. -1 / -2 / -3. I'm going to start combining these so we have space. So 4-3 is Tour. 2-1 is Top College. 0 is college. -1, -2, -3 is Top Amateur. All right. -4, 5, 6, 7, 8, and 9. Oh, actually, beyond that, less than -3 is amateur. Okay, so they're breaking this down to give you an idea of where you fit in the golf putting quality world. Okay, so the idea behind all of this is they're going to take these different measurements, give you a baseline based on how you aim, based on your start line. So actually, after you aim it and then you hit your putt, did you start it on the line that you were aiming on? So that means whether or not your putter face was square at impact. How good you are at short putting, how good you are at long putts, lag putts, where you're just trying to get it close. Based on all those things, they're going to come up with a core average and say, this is your your putting handicap. And using that, they're going to say, you are about like one of these guys. So if you're like a top amateur, your goal might be to get to college or top college. If you are top college, you probably want to get to the tour, blah, 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 that kind of thing. So this is what it's going to do. So the output of this is going to be a breakdown of this type of stuff. Okay? So for starters, we need to go ahead, We're going to do aiming first. So we're going to, each class will probably do an individual section of this. So we'll do aiming first. This breakdown, what we have here, this is overall average. So it's not per category, sorry. So this is the overall average. So if your overall average is 4 to 3, it's going to be like this, blah, blah, blah. Now, there's a per category average there for each individual thing. So for aiming, we'll come up with a formula, and 0 to 1.9 is a 4. Actually, I'm guessing he wanted to have that a 3. Yeah, so 0 to 0.9 is a 4. 1 to 1.9 is a 3. 2 to 2.9 is a 2. 3 to 3.9 is a 0. 4 to 4.9 is a negative 2. 5 to 5.9 is a negative 4. 6 to 6.9 is a negative 6. 7 to 7.9 is a negative 8. 8 to 8.9 is a negative 10, I'm guessing. Negative 10. 9 to 9.9 is a negative 12. And greater than or equal to 10, well, just greater than 9.9, let's just say, is a negative 14. All right, so that's the breakdown for aiming. Now, here's how aiming works. Now, first of all, these numbers, the 0 to 0.9, this is a number of inches away based on degrees. And we'll talk about that in a second. So here's their directions for a person doing measurements for aiming. So set up for 10 putts from 10 feet. So the person getting fit for this will be 10 feet away. They're going to hit 10 putts. Record how far from the center of the cup each putt was in inches. Okay, so they're going to measure from the center of the cup how far each putt ended up in inches. Let's see. All right, so they're going to aim. So they aim inches, so they'll do those measurements. So they'll have a number of inches. So like in their example here, the first one they were 3 inches, the second one they were ½ an inch, the third one they were 1 inch, 1 inch, ½ an inch, 1 inch, 0. So they must have made that one. 2 inches, 1.5 inches, 1 inch. We're also recording, did they miss it left or right? Okay, which side of the cup did they hit it on? And then based on that, they get a number of points. Okay, so in the end, we calculate a total distance missed. So in their example here, across the 10 putts, they missed the center of the hole by a total of 11.5 inches. They have this thing called pro point. So pro point for aiming is less than 1 inch right or left. Okay, so if you miss less than 1 inch right to left, you get an extra half inch, or yeah, an extra half inch added on. That's weird. We'll see how it works out. Today we won't have to deal with that. So we're gonna calculate the total pro points, the average distance in inches that they missed. So even though their total miss was 11.5 inches, their average was 0.8. So their aiming handicap is then 0.8. And 0.8 puts them in the 0 to 0.9 category, which is a 4. That make sense? All right, so what we're going to start off with for aiming is we're going to enter in 10 pieces of information. The 10 pieces of information we're going to enter in initially will be just how much they missed by. Okay, so we'll start off with that. Then we'll add in missing right or left and that kind of stuff, but we're going to create a data structure for capturing 10 putts, 10 pieces of information. We don't have to think about them as putts. How much each one missed the center of the cup by. From there, we're going to calculate, we'll calculate total distance missed, an average distance missed, and then based on that, spit out an overall handicap that follows this chart. That make sense? Okay, so that's what we're going to start with here for aiming. So if we're doing this, let's think about the data structure we built for this. Well, the entire project is probably going to be called something like Seymour or something like that. But one of the objects we'll have will be called aiming. Okay? The aiming object is going to probably take in an array of, well, actually, we'd probably read in the putts. So rather than taking an array, we'd probably ask, what's the first putt, what's the second putt, what's the third putt? For our purposes for testing, why don't we just hard code in those things in an array? Assume we read them in from the user, captured it into an array, and now we're working with that array. That way we can test it multiple times, and I have to go through this rigmarole of please enter putt number 1, please enter putt number 2, so on and so forth. Okay, so for aiming, the constructor will read in an array of 10 putts. In terms of distance from center of cup in inches. Okay, so that's what the constructor is going to do. It's going to read those things in. What do we need to store internally? Internally, we need to store a field that is a double for total missed inches. We'll have another field that is a double for average missed inches. And then we'll have a field for handicap. Okay? And these should probably be all private fields, correct? All right. Then we probably want to have getter methods for each of these private fields. So we can at least read that information out of our object. Does this make sense? So pretty simple object we're going to build, but I thought it'd be cool to attach this to a real world project so we can see how this stuff would come together. Okay, so we're going to come in here. We're going to create a new project. So a new Java project. We'll call this guy Seymour. And we'll go ahead and create a new class, and we'll call this guy Driver, like we usually do. And driver is going to have our main method in it. So I always start off with the original hello world just to make sure everything's connecting. So if we run our program now, we should get hello world printed out to the screen. Okay? And we all obviously have this completely memorized. You can write this 100% of the time, right? It should be ingrained in your soul how to write the hello world program. All right, now let's go create our object. New class aiming. Okay, aiming is going to have 3 private fields, 2 doubles, and a handicap will be an int, a solid number. Based on, this is our aiming handicap. Okay, so we'll go ahead and create our 3 fields, or variables. So the first one's called total missed inches, then average missed inches. So we will have private double total missed inches. Private double average missed inches. Private int handicap. All right, so aiming is going to keep track of 3 pieces of information. And this is for an individual person. So keep in mind the person who might be using this tool is going to be like a golf instructor or something like that. And they might have back-to-back lessons with 10 different people. So each of those 10 students are going to have their own instance of the aiming class that has their 10 putts and their total missed inches and their average missed inches. Make sense? Okay? So that's why we're writing this with a bunch of instance stuff in it, not putting static. All right, now we're going to have our constructor. Constructor is going to be named what? Aiming. Always the same name as the class, right? So public aiming. And we decided that this guy is going to read in an array of 10 putts in terms of distance from center of cup. And that distance will be a double. So this is going to be an array of doubles. So this guy's going to take in a double array called putts. Okay, and we happen to know this guy will have 10 buckets in it. So putts.length will be 10. All right. From that array, we need to add up the total missed inches. All right. How do we do that? So I need to go through, I need to add up all the crap inside this array. Remember, all hard programs are made up of a bunch of easy parts. How do I sum up all the putts inside of this guy? Maybe we should make that a quiz. Go ahead. By the way, this would be a very acceptable, very fair quiz to ask you to do this. So everybody in here should be able to do this. All right, go ahead. Okay.
Start at 0. Have to go through.
Well, you should still say putts.length, but you're right. We could hard code a TED in there in this case since we know, but better to use the generic version of this and say, I want to sum up all the crap inside this array. Okay, so putts.length, I++ each time. Okay.
Make another variable.
Okay, well, do I even need another variable, or can I use one of my guys up here? I'm essentially summing up everything in this array inside of total missed inches, right?
So you add array, the bucket 1
I need to start that guy off at 0. Okay, then what am I going to do?
Add bucket 0 to that.
Bucket 0. Why bucket 0?
Up to you.
What about the next time through?
Bucket I.
Bucket I. Putts at bucket I. Okay, so this loop's going to go through from bucket 0 to bucket putts.length minus 1, which is the legal buckets in our array. Each time through, we're going to take whatever the current sum is, total missed inches, and add to it the putt from that, the whatever values inside putts at that bucket. So at the end of this dot total misses should equal our total distance missed. Correct? Okay. How do we get our average missed inches? Okay. Or divide by putts.length to be more generic. But in this case, it is 10. But I mean, it's an interesting lesson. I would say you should never hard code a value in. Okay. There could be some exceptions to that, but there's not a great reason to hard code a 10 in here, just in case this place decides to change their system a little bit, and instead of measuring 10 putts, they measure 12 putts. If we hard coded 10 in here, we'd have to go through and change our code. If they change it to 12 and we make it generic, they can just send in 12 putts instead of 10, and it'll still work. Okay? So we'll say this dot average missed inches is equal to this dot total missed inches divided by putts dot length. Make sense? All right. So we've captured the first two pieces of information. Total missed inches, average missed inches, and now we need to calculate their actual handicap. Well, how do we calculate the actual handicap? Based on what they got out of that, this is their average missed inches, these numbers. Okay? So based on their average missed inches, we need to determine what their handicap is going to be. Okay? What would you suggest we do for this? For instance, the average missed inches was between 0 and 0.9. It should set handicap to 4. The average missed distance was between 1 and 1.9. It should set handicap to 3, so on and so forth. How would you go about solving this problem? Keeping in mind the same lesson about being generic. For instance, they might come back and decide, you know, our ranges are a little bit off, so we'd rather have it to be between 0 and 1.3 is a 4, something like that. So we want to make this easily editable in the future. So how might you go about solving this problem?
You could do a bunch of if and then also statements.
Okay, certainly could. So you would just say if average is less than or equal to 0.9, handicap is 4. Else if average is less than or equal to 1.9, handicap is 3, so on and so forth. Okay. Let's not do it that way. We certainly could, just to give you the first couple of parts of that. If this dot average is less than or equal to 0.9, then this dot handicap is equal to 4. Else if this dot average missed inches is less than or equal to 1.9, this dot handicap is equal to 3, blah, 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 blah. Okay? This would certainly work, but while it's generic-ish, where we can come in and change the 0.9 to something else. I'd rather be able to do this on one line rather than have to go through and potentially edit stuff across 40 lines of code. Make sense? Because I've only written the first two if statements. The next one's going to be if it's less than or equal to 2.9, then it's a 2. If it's less than or equal to 3.9, then I think it's a 0. It goes from there. So we need to have a more generic solution, really a more better solution to this. I haven't used that this year at all, have I? I fell out of the whole more better and most bestest. Yeah, we have to teach grammar in here. That's the problem. Okay. So how would you suggest we solve this problem? Go ahead.
You could have two arrays with your data, and they correspond to each other, being that 0 is equal to 0.9.
Okay.
And then you run through a loop, and then whenever it gets to the value that you want, if I is equal to whatever, then you set equal to the corresponding value.
Yep.
of the other array.
Okay. So we have a problem-solving concept called parallel arrays. In this case, we have two data points. We have an average miss, and we have a corresponding handicap. There is literally the identical number of average misses as there is corresponding handicaps, correct? So we would create two arrays. One array with our top line for each of our average misses. So we'd have 0.9, 1.9, 2.9, 3.9, those values in it. We'd have a second array of the exact same length that has the corresponding handicaps. So if our average miss is less than or equal to bucket 0 of this array, then our handicap is bucket 0 of this array. Does that make sense? All right. So this is typically how parallel arrays work. This is a common problem-solving pattern. So more than one array with the same number of buckets where each value at a specific index in the array is related to the values at the same index in the other arrays. Make sense? All right, so in our case here, we're going to build our two arrays. We're going to need this, this screen in order to do it. So 0.9, 1.9, 2.9, all the way up to 9.9. Okay, so I'm going to go ahead and at the very top of my constructor here, we're going to create a, actually I don't need to do it at the top of the constructor, we'll do it down here where we need it. I'm going to add some comments in here. So this is calculate handicap. This guy is calculate average. And this guy is calculate total. Those are our three pieces of information we're calculating. So for handicap, we're going to create two arrays. We're going to create, and in this guy, what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different categories, right? Okay. Really, we have 10 categories. And then everything that falls outside of that is this other one. Okay? But we'll do 11 for now. That way we can keep track of this number. So we're going to create a double array called average misses. And this guy is going to be equal to 0.9, comma, 1.9. What did I say, 11? It's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2.9, 3.9, 4.9, 5, 6, 7, 8, 9. And then this last number, we can just put in a -1, something like that. Or we can put in a gigantic number. Doesn't really matter because we're not going to use that value. So I'm just going to put a -1 in for right now. Okay. Similarly, we'll create a second double array. Called handicaps. And this guy's going to be filled up with 4, 3, 2. Zero, -2, -4, and then 0, -2. No, I'll go ahead and put spacing in because I prefer spaces. -2, -4, -6, -8, -10, -12, -14. And I'll go ahead and space these guys too. I just think it's easier to read this way. It's not required. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these, and there's 11 of these. Okay, these are two arrays that we're solving a problem using them as parallel arrays because they have the same number of elements in them. Go ahead.
Do they have to be the same type of array? Like, do they have to both be double arrays for
No.
parallel? So
Well,
you could make the other one like an interarray.
Absolutely. I mean, understand that parallel arrays, all they say is we're solving a problem with multiple arrays that have the same number of elements in them. Because bucket 0 of one of them is related to bucket 0 of another one, is related to bucket 0 of another one. The types of values that are in there are insignificant. So sometimes you might have first name, last name, age. 2 strings and an int or something like that. Okay. Now, that I have these two parallel arrays, how will I go through and set up handicap? So if I have two arrays, if my handicap is less than or equal to 0.9, or if my average miss rather is less than or equal to 0.9, my handicap is 4. If it's less than or equal to 1.9, but greater than 0.9, my handicap is 3, so on and so forth. How would I solve that? Go ahead.
For loop through, and then just have a if statement.
Okay, well, we're going to do a for loop. How many buckets are going to be in the for loop?
Average on this.
Okay, or I could say handicaps.length. Correct? Doesn't matter which of those I use because they're the same length. So I'll create a for loop for int I is equal to 0. I is less than average misses dot length I plus plus. Okay. And you said we want to ask a question.
Yeah.
So if what?
Average miss or average miss inches.
Yep, average miss inches, this guy. So if this dot average missed inches
Is less than or equal to average misses at I, then you can change your handicap to handicap at I.
like that. What do I call it? Handicaps? Handicaps. Oh, I made this dot handicap. Well, actually, this is the answer to your question. I made this guy a double, but it didn't need to be double. He's filled up with integers, isn't he? So
That's why
I got it, yeah. So I did this on purpose. So still parallel arrays, but one of them holds doubles, the other one holds ends. So this dot so it was yelling before because I was trying to stick what it believed was a double into an integer. So this dot handicap is equal to handicaps at bucket I. Okay. Now if I did find my handicap, what do I need to do? If I have my answer, do I want to go through this loop again? I need to get out of this loop. How do we break out of a loop? Hint, hint. Break. So break breaks us out of the most local loop. Correct? All right. So this is what we'll do as we go through here. If our average misses is less than or equal to 0.9, we'll set handicap to 4 and break out. Otherwise, we'll spin back through. Ask, is average misses less than 1.9? Less than or equal to 1.9. If it is, handicap is 3. We're going to get all the way here to the end. And we're stuck with this guy. How do we handle that? We can certainly put a gigantic number in here. 100,000. Will anybody have an average miss of 100,000? Very likely not. But from a generic point of view, is it ever safe to put a high end on the number? This is something that old programmers used to do. In this case, because we understand the problem, it's probably fine. But we're going to pretend like we don't necessarily know. Okay? Potentially we're dealing with a very dysfunctional golfer who probably should not be putting. If their average miss is more than 100,000 inches, they don't belong on a golf course. But we're going to still write this generically. So how do I handle this case? Notice I've put in a -1 as my final case there. So when I get to the very end, the last time through this loop, if I haven't set a handicap yet, what am I going to do? How do I handle that final case? I really need to treat it as a special case, right? Is it true to say that if I checked all of these except the last one, that my handicap will equal this guy's last one, if I'm still kicking? Correct? Okay. Could I do this before my loop? Could I say something like this dot handicap is equal to handicaps at bucket handicaps dot length -1? Could I set it to the worst case and then go through and check all of them except the last one? So when I'm done with here, when I'm done with this for loop, one of two things has happened. I've either found a better match and overwrote handicap with the correct value, or I may have checked all of them and none of them fell into this range because I went to -1. I went to average misses dot length -1, so I don't actually check this last one. So if I've gone through this entire loop and I've exited naturally, means I've checked every single bucket and I never hit this break because I never got inside this if statement. What is my handicap set equal to? In this case, 14. So it's still correct. Does that make sense? So right here, we are set handicap to worst case. Then check all the other cases to make sure there isn't a better fit. When we're done here, we know that handicap is set correctly. It either stayed the worst case or we replaced it with a better fit, a better answer inside this if statement and then broke out of our loop. Does that make sense? Okay, so this is our constructor for aiming. Now, think about what constructors do. The job of a constructor, if you had to concisely define what the job of a constructor is, what would you say? By the way, this is the point where I'd be sipping coffee, just so you remember. We have a 7-hour road trip a week from tomorrow that Abe will be coming on, and if I don't have coffee in my hand, I get grouchy. I should have some of you guys drive, that way I can play my video game. No, I play Hearthstone now. What's Hearthstone?
Kill
Have you ever heard of Magic the Gathering?
Yes.
It's a trading card game. So think Dungeons and Dragons-y, but card-based. I'll teach you all about Hearthstone during the... It's actually a really cool game.
Does he know about Dungeons and Dragons?
And it's, yeah, you've heard of Dungeons and Dragons, right?
So last semester you didn't know what it was.
You're like married and stuff, right? So you're like, how old are you? 21, 22? 19? Oh my God. These Concordia guys, they get married so young. What's up with that? How old were you when you got married? Oh, well, could have been worse, I guess. Well, no, the thing is, yeah.
So that's Amish.
Amish's first marriage. Well, they married me off the first time at 8.
That didn't work out.
2 sheep and 3 goats was, I guess, the trade value. It's not just him. It's like it seems to be a Concordia thing. Seems like a lot of Concordia students get married like very early. Have you noticed that? I wonder what's the deal. I don't get it. Maybe it's not a Concordia thing. Maybe it's just because I'm at Concordia. It seems like it. Maybe it's a modern day. Oh man, I thought I got married young. I got married at 22. I'm like, man, if I had to do it over again, I would have got married at 40. Well, I'm stuck with my wife now, so I'm just.
And that's on the recording.
I could text it to her. Nothing I would say on the recording is. I wouldn't say anything on the recording that I wouldn't say right in front of her. Because she's on the worst end of that deal. She's stuck with me.
Text her later. Watch this video. This class is
She makes a lot of cameos. What was the question I asked?
If you knew Dungeons and Dragons, then you got mad.
No, before that, I segued away from something. Huh? Ah, that's right. Where did that come from? Okay. So if you were to give me a concise definition of a constructor, what would you say? That's the new keyword. New keywords are real estate and it goes out and requests memory. What's the job of a constructor? Every single object, every class we make has a constructor, whether we wrote it or not. If we didn't write a constructor, it comes with its own no argument constructor that does nothing except build us a generic object. But if you had to concisely define, or even inconcisely, long-windedly define what a constructor's job is, what would you say?
The object.
Say this again?
It builds the object.
Okay, builds the object. What does it mean to build the object? What's entailed with building the object?
It sets up any fields or procedures that the objects are supposed to.
Okay, so realistically, the job of a constructor is to initialize all the fields. The methods are written outside the constructor, right? But when you build an object and you call it constructor, the job of that constructor is to put all the necessary values in place in the fields so that all your methods will work. Correct? All right, so like the person who's in charge of constructing a house needs to put all the doors on and stuff like that so that ultimately when the house is done, people can go and live in it. They can go in and out of the door and there's beds in there, whatever it is. That's the dealio. Okay, so that's the job of a constructor is to initialize it. So what are we doing inside of this constructor? we have 3 fields. We initialize our first field, we initialize our second field, and we initialized our third field. Make sense? That's what this constructor did. From here, we can now write our getters. We can have Java automatically create them for us, Eclipse automatically create them for us. We can right-click here and say, was it source, generate, getters, and setters. We'll select all of our guys, but within each one, we only want a getter. We don't want a setter. So we'll unclick set, set, and set. Make sense? So this will create those 3 methods for us. It'll create a get average misses, it'll create a get handicap, and a get total missed inches for us. And each one of them is just 1 line long. It'll return this dot total missed inches, this dot handicap, so on and so forth. Okay? So this is just nice built-in syntactic sugar for generating simple but useful methods. Why did we need those methods? We needed them because these guys are all private fields. We cannot access them directly. Make sense? Okay. So let's go and now test our aiming. Now, in order to build an aiming object, in real life, we hired somebody to build a house. What do we have to give them? Cash, right? That's the input. You hand them a big check, and they go and build a house for you. In this case, what does the constructor for aiming require? It requires us to give them an array of doubles representing our putts. Okay? In this case, we're going to give him 10 putts. So I'm going to go ahead, and I'm going to create a double array called the putts. And this guy is going to be equal to a set of 10 putts. Now, in our final program, we might ask them, enter putt 1, enter putt 2, enter putt 3, you know, that kind of stuff. But in here, we're just going to hard code it for testing purposes. So I'll actually use the putts that they put in. So we're going to say 3, 0.5, 1, 1, 0.5, 1, 0, 2, oh, actually hit the brightness button, 1.5 and 1. Okay, so there's my putts. Now we've seen the syntax, the shorthand syntax for building arrays before. This is equivalent to saying double the putts equals new double 10. Double at bucket, the putts at bucket 0 is 3, the putts at bucket 1 is 0, the putts at bucket, 0.5, the putts at bucket 2 is 1, so on and so forth. Okay? So now that we have that array, we're going to create an instance of aiming. Aiming A is equal to new aiming, and we'll pass it the putts. Okay? Then we'll go ahead and print out our 3 pieces. So we'll say system.out.println total missed a.get total missed average missed a.get average missed and handicap. A.get handicap. Okay, we'll go ahead and run this guy. We see our total missed was 11.5. Our average missed was 1.15, so our handicap was a 3. Okay? because our average missed was greater than 0.9, but less than 1.9. That's why our handicap was a 3. Make sense? Okay. Questions about that so far? Okay. So now, let's take into account trying to understand their calculation here. So it seems like the numbers they put in here, these guys, were not actual inches missed. Instead, they were degrees. So this is from building a triangle, I'm guessing. So they gave an example of 1.05 inches is equal to 0.5 degrees. So for instance, this guy would have been a 1.5 inch missed putt. So 0.5 degrees. And we'll try to figure out how they solve that here in a second. 3 would come from a missed putt of 6.28 inches. So this guy was actually 6.28 inches from center. So we missed it pretty wide, relatively speaking. I mean, having a 6-inch putt coming back is not a big deal. Okay? That's a kick-in. But relatively speaking, that's a pretty big miss from... so let's see if we can figure out how they did that. So we're going to go ahead and add a screen. We're going to draw... Oh, I love pictures. We can make that bigger than that, right? Okay. Here's the cup over here. That's where we're aiming, is that guy. And obviously the golf cup should be a different color. There we go. Oh, everybody relax. There. That's the golf cup. We know that this is 10 feet, correct? That's the distance of our putt. So that's 10 feet. We don't necessarily know this, correct? This is our measurement, number of inches we missed from center. So for instance, in their example here, this is 6.28 inches in one of their examples. Okay, 6.28 inches. We probably need to make that into feet so that so this is opposite over adjacent, correct? To figure out this guy. What's opposite over adjacent? Which trigonometry function is that? Opposite over tangent. So opposite over hypotenuse is sine. Adjacent over hypotenuse is cosine. Opposite over adjacent is tangent. I think that's right. Haven't you guys had these math classes way more recently than I have?
No. Yes, but no.
So what's that, college algebra? Well, it doesn't matter. You took algebra in high school, didn't you? Yeah, you're laughing about it. I haven't had that in years, like way over a decade. Way over a decade. I haven't had that in 20 years. That's embarrassing. I haven't had that math longer than most. I haven't had that. He's married, and I haven't had that math since before he was born. Killing me. Okay, so the formula for this is the tangent of x is equal to, we need to do inches to feet. So how do you, 6.28 divided by 12? That's the number of feet that 6.28 inches is. So 6.28 divided by 12. Oh, didn't they give me the answer? Dreamweaver. That's the answer. So the answer is Dreamweaver. So we need to convert that into degrees, obviously. All right. I actually just learned this the other day. Did somebody in here teach me this? So you can do math in here. 6.28 divided by 12, just like you can in Google, is 0.5233. So this is actually, I'll just put it on a second line, 0.5233 feet. Now here, we spelled out feet before. All right, so we want to do all our math in feet. So the tangent of x is actually equal to 0.5233 divided by 10. And 0.5233 divided by 10 is 0.05. So tangent of x is equal to 0.05233. What's up?
The calculator was really necessary for that one.
Yeah.
Hey, look, I like my calculator. All right. See, I bet you half the people in class don't even get why you're making fun of me. That's what's funny. Raise your hand if you know if you get why he's making fun of me. See, some of the other people don't. Dividing by 10 should be pretty easy. Just move the decimal place. That's what he's making fun of me about. All right. So tangent of x is equal to this. So how do we calculate for x? Well, this is algebra. Well, it's trigonometry, part of algebra. So how do we calculate x? I wonder if my calculator does. So they're saying the answer for this one should be 3. Tangent of 3. That's interesting. So they're saying that I'm saying the tangent of their final answer for this one for 6.28 inches is 3 degrees. So if this is in degrees, oh, I wonder, is this radians? Is negative 0.14 radians. We might have to go to Google for this one. Negative 0.143. Negative 0.143 radians to degrees is negative 8 degrees. Well, they're coming out with 3 degrees, at least in their map.
If you type in 3 degrees, it has 3, like 3, and then there will be degrees after it. And then come back, like put it, yeah.
Oh.
There's 6 degrees in Kevin Big.
And that's close to it.
Yeah, that is close to it. So oh, I was probably doing my tangent in radians. So we need to first well, we have to see what Java's tangent does. Does it take in radians or does it take in... But regardless of that, before we even get to there, we need to fix this formula. So what's the inverse of tangent? Arctan? Okay, so if we multiply the left side by arctan, does that get rid of the tangent? Is that x is equal to arctan of this right side? Is that correct? And we decided this is in, well, who knows what that's in? Well, we know it's in feet. Can we take the arctan of that? Arctan should only work on degrees. I don't think this is right. Is it? How do we solve tangent of x equals 0.05? No, I think that was right. I think it's the arctan of 0.05. Let's look at Google here. It's 0.05 radians. So that's basically what we had. Okay, so this is our formula. So our degrees here is 0.05 radians, which is actually 3 degrees. 2.86, whatever. Okay, 3 degrees. So we need to do this math. So we did all the math. Now we just need to do the arctan of that number. And where did that number come from? That number came from tangent of x is 0.5233 divided by 10. So that's opposite over adjacent. So our angle is the arctan of this math right here. Then converted 2 degrees. But let's get the radians number first. And it's possible that Java already does the conversion. All right, so in order to do this, we need to learn how to do the trigonometry functions in Java. Good news for us, just like on a calculator, there's a button for all these guys. So I'm going to go into the Java documentation. There is a class called java.math. Isn't it in java.math? No, it's in java.lang inside of a class called math. So here's the math class. Here's our arctan. Returns the arctangent of a value. The return angle is in the range of negative pi over 2 through pi over 2. That's okay. I think it's in radians, yep. So we're going to get that number. So we need to do the arctangent of our inches divided by 12. Okay, so as of right now, we got to go back to our code here. All of these numbers are given in those angles. Okay, so we need to have a function that converts those things to degrees. Does that make sense? So let's write it out here first. So we'll write a static method, class method, since we're writing it inside of driver, so it's going to be a static context. And we'll have this guy return a double for now. And we're going to say inches to degrees. This guy will take a double inches as a parameter. Okay, and we're going to ultimately return a degree value as a double. Also, we need to look at our math here. We want the arctangent of inches divided by, we know it's 10 in this case. We have our little sample thing here. We're going to put that in. Later on, we might make it more generic. So number of inches. So we're going to say math dot, well here, let's say double feet is equal to inches divided by 12. Okay? So that gets us our number of inches in terms of feet. Then we're going to say double, probably radians, is equal to math dot atan. Oh, it looks like there's two versions of the, oh, the second version is going to take in, oh, it allows you to do polar coordinates. We don't want that. All right. So math atan, and we're going to do feet. Well, our variable feet divided by 10. Okay? And then let's go ahead for right now, return radians. System.out.println driver.inches to, and I think I did 6.28 was our little example we were working through. So we're going to see if this gives us the degrees. Does it give us something close to 3, or does it give us something close to 0.05? Gives us something close to 0.05. So now we need to convert that to degrees. Radians to degrees.
Plus Java for having the 2 degrees function.
Does it really?
Yeah.
In math?
Yeah.
Let's look at the documentation. Is it called 2 degrees? Is it called radians 2 degrees?
Just 2 degrees.
2 degrees. So it takes in a number of radians and converts it 2 degrees. And again, we'll see it is a class method that lives in the math class. So we'll say math dot 2 degrees and pass it in the radians. Math dot 2 degrees. The input will be radians. And this should give us something like 3. Make sense? And it looks like all of our answers are to the closest 0.5. So we also have a math dot round. I think it's going to round to a whole number. Well, we'll mess with that next time since we're out of time. But we're going to want to round this to the closest 0.5. We can write our own little thing to do that. It's not going to be that part's not rocket science. Okay, so we seemingly have the conversion here. So next time we'll come back, we'll finish doing this conversion. We will add in this idea of pro-points that they have here and go from there. Sound good? So kind of cool. We're solving a real-world problem here, thrown in some math, but we see, hopefully, that math like this wasn't overly difficult math. We had to kind of rack our brains a little bit, but now we start seeing a reason for some of that trigonometry stuff we did. Make sense? All right. I'll see everybody on Tuesday.